Okay, welcome back everybody. So we are moving on in the second course objective here about aquifer property and identifying groundwater. And so today, after this little introductory video with the sandbox, we'll go into more details about identifying underground water and nomenclature of aquifers. Okay, so the main question here for this lecture that we haven't really talked about yet is where does it go? Where does that rain? Okay, we have some rain falling on the ground, it infiltrates, and then what, right? What becomes of it? Here's a little example that I really like, a famous Okavango River delta, and again on the left-hand side you have a satellite view of, you know, the southern half of Africa. And you can see that the Okavango source is up here, and then here you can clearly see a delta, an inland delta. So usually when we think of a delta, we don't think of inland, right? The delta is in the sea, so the river goes to the sea and then pours out its sediment, and you have a formation of a delta. The Okavango, right, just pours out its water and alluvium on land, so literally the whole river disappears, and this is a huge delta. I mean, you can see it on the satellite view. It's a very famous UNESCO site, like a very famous, you know, worldwide recognized site for nature. It's just an amazing wetlands, and it changes inside about 2 times during the season when it's wet or dry. A beautiful, beautiful place that I recommend you guys go and look at some National Geographic. You know, there's a lot of wildlife. It's an amazing place. But the point is, the water disappears. Where does it go? Here on the right-hand side, you can see the Colorado River Delta in Mexico. So it's a different story, right? So in this case, where does the water go? Well, we kind of know because it goes in the fields, right, in California, or in the houses in Phoenix, right? So there's so much use of the water that the Colorado River, which is, you know, a huge river, basically goes down to a trickle and doesn't really reach the sea anymore. There's been some conservation effort to like put some more water in, you know, to restore some of the ecosystems down there, but really, you know, the problem is we use so much that it doesn't flow anymore. Yet still, right, the water at some point goes down to a trickle and disappears. So where does it go in the ground? So here is another similar, you know, conceptual illustration here, where you can see an infiltrometer. So basically measuring, you know, infiltration of water in the ground, how fast does it disappear, and you can see it's basically just a piezometer or a PVC pipe, and you pour water, fill it up with water, start a timer, and then after some time, you know, make a mark, and you can calculate, you know, the infiltration rate. So, you know, centimeters per hour or whatever the units are, but, you know, the water goes down, you know, into the ground, into the soil. Where does it go? Okay, so here is a little sketch that's from the USGS, and you can find a similar illustration in your books in FEDER, chapter 3, figure 18. And this is, you know, the usual nomenclature of underground waters. So what we're mostly interested in this class is the saturated zone. So saturated means, you know, it's full of water, basically. There's water everywhere in all the pores, and so there's just like rocks or sediment and water. Then above that you have what we call a capillary fringe, and this is a place basically where suction, right, in the pores can hold some moisture, and then above that there's an unsaturated zone. Well, the unsaturated zone goes down to the water table. So this is here, really the water table, which is, you know, that surface of the water that is completely saturated. And in the unsaturated zone, there's a soil zone, or a root zone, or a vadose zone, which is typically where those roots are. And then down there's some more unsaturated space. Unsaturated means that there may be some water and some air. So now we have a two-phase flow problem where there's both air and water circulating through those pores, and that, you know, leads to very different hydrology, very different transport processes, and we will not talk too much about it in this course, but this is a whole topic in and of itself, the vadose zone, the soil zone transport, basically. So this is really where it is. So of course, when there's precipitation on land, then the water has to go all through here to reach the water table. Again, you might have some water that flows, you know, sideways directly to the rivers. There's a lot of complications in that unsaturated zone. And of course, as we've seen before, a lot of that water gets trapped in the soil zone and in that unsaturated zone, and then is evaporated back to the atmosphere. Okay, so this is really what this class is about, right? Groundwater. So really the saturated zone, the aquifers. So what are those? Here's another look at the same or similar cross-section, basically, of the underground, you know, water, and this is from Bear 79. So if you're really interested in, you know, pushing the envelope and going to the next level with your groundwater knowledge, I really highly recommend that book. This is really a complete book, and there's a lot of, you know, all the mathematical equations are derived. This is a very excellent book. But again, you can see those same definition with the saturated zone. Here he calls it zone of aeration, the unsaturated zone. So again, this is what I just explained. There's air and water in there in various amounts. That capillary fringe, the water table, again, is that, or here we call it phreatic surface, which is a synonym to water table, essentially. So here in the Bear, he says water table is at the surface of the capillary fringe. In my nomenclature, or what I use, is water table is the surface of the saturated zone. So it's the same as the phreatic surface. Here there's a well illustrated, and again, there's a whole course, a whole nother one-credit course in this sequence that is about well hydraulics. So if you're interested in that, you should go and check it out. And again, the soil and root zone is at the surface here, and then the ground surface is there. And you can see here that water table dipping to the river, and we'll study these zones, you know, these riparian, basically outflow of the groundwater to the river in this class. Okay, now moving on to the actual aquifers and their definitions, right? So there's essentially two main types of aquifers, which are confined and unconfined. So again, in the Bear book, he uses phreatic. What that means is unconfined. What we'll use in this class is unconfined. So the two main types of aquifers are unconfined and confined. So unconfined means the water table is touches the atmosphere, if you will, or touches that unsaturated zone. So there's a proper water table. A confined aquifer, as you can see here, and there's another one here, is an aquifer that is between formations. So it is sandwiched here by some kind of an impervious layer at the top. So these are waters that are typically deeper in the ground, oftentimes cleaner because there's less, chances of pollution from the surface of the ground, down to the aquifer. So those confined aquifer are deeper and have typically cleaner water. But again, by definition, they are confined. Then there's some leaky confined aquifer. So this is a confined aquifer that may exchange water with another aquifer on top, right, across that less pervious formation. So if the formation is leaky a little bit, so it's not completely, impermeable, then there's some exchange, and that's a leaky confined aquifer. And we'll talk about those three types mostly: confined, unconfined, and the leaky confined, which is basically an in-between case. Now here you can see you have perched aquifers. So these are like pockets of water that are retained by a bottom impervious layer. So if you have a clay layer, for example, in the ground that may retain some water, so this is like a perched aquifer. We also talk about those flowing wells and artesian, what we call artesian aquifers, which are basically aquifers where the pressure, the head, right, is higher than the ground surface. So then if you poke a hole, water is pushed out to the ground surface. Again, some useful definitions here that I've already touched on. So a confining layer is a unit with little or no permeability. I haven't really talked about permeability, but that should be intuitive, so water cannot go through it. An aquifuge, again, is a completely impermeable unit, right? So no transfer. Aquitard is when those leaky confined aquifer come in. So it's like a formation that is a little bit permeable, but not very much, right? So very low permeability. So again, unconfined and confined is really the bread and butter of this class. So that's an aquifer without or with a confining layer on top. The leaky confined I already touched upon is the confined with that aquitard on top. So there's some leakage. A perched aquifer, I just showed it on the previous graph, is that layer of saturated water that forms due to the accumulation above an impermeable lens, for example, the clay. And then the water table, again, is the depth where the soil becomes completely saturated. Okay? So these are the important definitions for this lecture. Okay, I think I'll leave it here, and I'll see you on the next video. Thank you.